Good afternoon. Our next speaker, Dr. Jeffrey Bennett, will be talking about Beyond UFOs, the scientific search for extraterrestrial life. Dr. Bennett holds a BA in biophysics from the University of California, San Diego, and an MS and PhD in astrophysics from the University of Colorado in Boulder. This extensive knowledge and experience in research his extensive knowledge and research includes serving 2 years as a visiting senior scientist at NASA headquarters in Washington, D.C. He's a best-selling author in college textbooks in astronomy, astrobiology, mathematics, and statistics, as well as award-winning children's books. He has an amazing background, and I'm very much looking forward to Dr. Jeffrey Bennett. So let me bring him to the stage.
Thank you. Thank you very much for having me here today. It was, I've actually spoken to UFO groups a number of times before I even got to be on a really fun local TV show called Men in Black a few years ago. And so when James Carrion called me up a few months ago and asked if I'd be interested in talking to you, I thought it would be a great opportunity and a lot of fun for me, because even though as a scientist we come at these things from a little bit different perspective, what I like to focus on is the fact that we share common interests and a common amazement at what it would mean to us to really know that we are not alone here in the universe. And so one of the gentlemen I was speaking to beforehand came up and asked if I was your token skeptic. And I said, well, I guess we could look at it that way. But hopefully what I like to focus on is that the differences between the way science comes about something, the way some of you might be going about the same sort of question, are a lot less important than the commonalities in what we're trying to search for and the answers that we all seek. And I think if we focus on those commonalities, then we can bridge the gap, which is what James Carrion had asked me to talk a little bit about and try to do, that sometimes seems to get in the way, and thereby be able to move forward together to try to answer some of the most amazing questions that we've ever faced as a civilization. To give you a little bit of a sense of where I come from with my perspective, let me start by telling you a little bit about how my book, Beyond UFOs, which I assume you can see on the screen there, just like I'm seeing on my computer. Nod your heads. Okay, good. How that came to be. So I'm, as John mentioned, I'm an astronomer, and I wrote a college textbook for astronomy that's the most widely used college textbook in that subject in the world right now. And after that, astrobiology is starting to become a growing subject of great interest to lots of college students who are not majoring in science, but they want to know about the search for life in the universe. So I ended up writing a textbook for astrobiology. Also, my co-author in that book, some of you may have heard speak before, Seth Shostak from the SETI Institute. So Seth and I worked together on that college textbook. And in the process of working on that textbook, I thought, well, this is really great, I hope, for someone who's got a whole semester to spend 15 hours a week studying. They can learn a lot here. But what about people who don't have a whole semester and 15 hours a week to devote to it, who just want to be able to pick up a book, read for a couple hours, and get some sense of what science is doing with the search for extraterrestrial life? So I decided I would try to write a book for the general public that could be read a lot more quickly than a college textbook that requires in-depth study. And I very quickly came up with the title that you see there, Beyond UFOs. And it's not really meant to be a pun or a bait and switch or anything else. It was meant to be exactly what I like to do, which is because I'm a skeptic about particular UFO reports, but I'm a believer in the possibilities of aliens and alien life out there, I thought, let's get beyond the part that we argue about and talk about the part that we can all be commonly interested in. So that's where the title came from. But I have to admit that I thought there was a little bit something maybe misleading about the fact that I had the word UFOs in my title when I had never seen one myself. And this is a true story. Not 3 weeks after I came up with that title and started to work on the book, I was out on my deck with my son at about 3 in the morning. We were actually looking for a meteor shower, when we saw something that did not look like a typical meteor. We're watching, and all of a sudden there's this dot up there, and it gets brighter and brighter. It's not moving. It's getting brighter and brighter and brighter and brighter until it is by far the brightest thing in the sky. This all happens over a period of about 10 seconds. And then it disappears. Now, I thought it simply disappeared. My son said he saw it shoot off. Now, I don't know why we saw it differently. He's got better eyes, being young and me being old, so probably his account is more reliable than mine. But whatever it is, there was something that had happened. I mean, truly, as an astronomer, the first thought that entered my mind was, oh my God, it's a supernova of a nearby star. But that would not have disappeared in 10 seconds. That would stay bright for months after that. So what was it? Well, clearly, it was an unidentified flying object, because I don't know what it was. By definition, it was unidentified. So what was it? And the answer, of course, is I still don't know, and I probably never will. But I think I can give you a sense of where different people come from at this. If I really wanted to believe, it had all the characteristics that we might expect from an alien spacecraft coming in to check things out, right, and then disappearing. So I could believe that that was the explanation. My own personal favorite explanation is that even though it didn't have any of the characteristics of a typical meteor, maybe somehow it was a really unusual one that happened to be coming straight at me rather than off at an angle, so that it would get brighter and brighter and brighter until it disintegrated, which could explain both its disappearance and maybe a fragment shooting off that my son saw. But a lot of my scientist friends say, you know, that doesn't quite work for us. It's still too far off of the typical meteor behavior. Maybe an iridium flash. Maybe some of you have heard about that. So there's a whole lot of different possible explanations for what this could have been. And I'll tell you, my personal best guess is I still would go for the meteor. My personal best hope is I hope it was the alien spacecraft, because I really want them to be coming here and visiting us. And so the only difference between my perspective and maybe the perspective on some of you is whether I'm convinced that they're already here. I'm not. Maybe some of you are. But it doesn't mean I don't want them to be here just as much as you do. So with that in mind, I started to think a little bit more about what is it exactly that makes the perspective in science a little bit different from the perspective in UFO research and so on. And it took me back a couple thousand years. I've spent a lot of time studying the history of science and so on. And a lot of people think that this question of extraterrestrial life is a relatively new idea, but it's not. It's been discussed way, way back, and these two quotes will show you. Epicurus in 300 BC, so 2,300 years ago, writing, "There are infinite worlds, both like and unlike this world of ours. We must believe that in all worlds there are living creatures and plants and other things that we see in this world." He's taking a viewpoint not only that extraterrestrial life is a possibility, but that it's required. It must be there. There must be other worlds. Now, if any of you have studied philosophy, you may know that Epicurus was one of the original atomists who believed in the infinite atoms making up the universe, and his perspective comes from there. If there's infinite stuff, then what happened here has to be happening all over the place. Aristotle, around the same time, a little bit later, writes something completely different. He says this world must be unique and completely rules out the possibility of there being any extraterrestrial life. Now, how does Aristotle do that? Very simple. Because the atomists have this infinite universe that they believe in. Aristotle believes that the universe is made of fire, water, earth, and air, that Earth has a natural motion, which is to fall towards the center, and therefore, by definition, all the Earth in the entire universe must be at the center, which is where he believes Earth is. And therefore, Earth, what we live on, is the center of the universe and is all the Earth there is in the universe, so there couldn't possibly be another world like this anywhere else. Otherwise, it would have fallen to here. So very simple how you get this. The amazing thing about this is that this debate, in pretty much the same form, stayed unchanged for pretty much the next 2,000 years. It wasn't just an occasional debate. It was a constant debate. This debate had huge implications to the history of Western civilization. The Catholic Church had great debate over it. St. Thomas Aquinas came in on it. I forget exactly where, but he spoke of it. Others spoke of it. There was a great debate within the church about whether the view that there's other worlds with life was in contradiction to the Bible and Jesus having come here. And some of you may know that even today, there are some fundamentalist religious groups that say that extraterrestrial life is incompatible with the Bible. If you look at the Catholic Church and most other religious groups today, they pretty much long ago said, you know what, the Bible doesn't really say anything about any other worlds, so I guess they could be. It doesn't conflict. But there are some people who think there's a conflict even today. And it had a huge impact on the debate for thousands of years. And what I find most fascinating about this is you can ask, why is it that this debate was able to stay unchanged for almost 2,000 years? And the answer to me is because it shows that it's possible to argue endlessly as long as there's no actual facts to get in the way. And that's where science comes in. Because the debate did not stay unchanged forever. It stayed unchanged for almost 2,000 years, but it eventually did change. And what changed it? What changed it was what we call the Copernican Revolution, when Copernicus proposed, actually reproposed, an ancient Greek idea that the Earth is not actually the center of the universe, but instead is going around the sun as a planet. That idea was actually proposed by Aristarchus in about 260 BC, but wasn't bought by his colleagues at the time. But Copernicus comes along in the 1500s and says, you know, Aristarchus had a pretty good idea. And he was aware of Aristarchus' work, so he knew he was reproposing an ancient idea. But he worked it out and thought, you know, this actually, to him, made more sense than the Earth being the center of the universe. But he couldn't prove it. Tycho Brahe, Kepler, Galileo, and Newton ultimately came up with all the evidence and the modeling that made everyone realize, yes, Copernicus was right. So ultimately, we came to the conclusion that the Earth is not the center of the universe, it's a planet going around the sun, and the scientific evidence for that became so well established that no one doubts it anymore. What did that do to this ancient debate? Well, remember, Aristotle's entire premise that he used to say there couldn't be any other worlds or life anywhere else was based on the fact that he believed Earth falls to the center and Earth is the center of the universe. The moment we learn for sure that Earth is not the center of the universe, that means Aristotle was wrong. The entire premise of his argument was wrong. Earth is not the center of the universe after all. That doesn't automatically mean that Epicurus is right, that there are lots of other worlds with life on them elsewhere. It just means that stating emphatically that there aren't is not something you can do anymore. So from the Copernican Revolution, it opened up, for sure, the possibility of all these other worlds with life. And I'll take you from there, but before we do, I want to talk a little bit about what that tells us about the nature of science and how we go about things in science. And if you read my book, you'll see I spend quite a bit of time talking in some depth about the nature of science and what constitutes science. But I like to focus on two characteristics in particular that I think are the most important characteristics of science today. And the first one is that science is a way of distinguishing possibilities from realities. And I think this one will be very easy for all of you to understand in terms of the case of UFOs. The possibility that we are being visited by aliens and UFOs is a possibility. The question is it a reality? I know a lot of you believe it is. I still put it in the possibility category. I don't put it in the non-reality category. It's a real possibility. And the goal of science is eventually to accumulate enough evidence to convince me and everyone around you, one way or the other, that it either is a reality or that it's not a reality. Personally, I suspect eventually we'll find it is. But so far, it hasn't reached the level that's convinced me personally, or many of my scientific colleagues. The second thing is that science is a way of helping people come to agreement. You go back to that ancient debate, and for 2,000 years they argued about this thing. And then all of a sudden, science came in, proved that Earth is a planet going around the sun, and suddenly we had agreement that one of those could be ruled out. Aristotle's view could be ruled out. The same thing, in principle, will eventually happen with this subject of alien life. Right now, there's disagreement between people who believe that the UFOs are a reality and people who are so far unconvinced. But if we keep studying it enough, eventually we'll get the data and the information that will make us all agree. The goal of science is to help us figure out what's real and what's just a possibility, and then to figure it out in such a way that all of us can agree on it. And so with that in mind, I think we can see where that bridge comes in between UFO research and scientific research. We're focusing in different areas, but we're looking at the same kind of questions. From my perspective, what I like about the scientific part is that there isn't really any room for disagreement on that part. If we find life on Mars, it's life on Mars. We all agree on it. If we get a signal with a SETI telescope, we got that signal. So by working in the scientific realm, I can focus on the part where there's going to be very easy agreement. And if we keep pursuing that, eventually it may overlap into the realm where I know a lot of you are working. And so with that in mind, I want to start talking about what science has to say today about the possibility of extraterrestrial life. Scientifically, we cannot yet say whether extraterrestrial life exists. What we can say is that the science that we've been learning, and the more we've learned, and especially in the last couple of decades, the more the case has grown that extraterrestrial life is a very, very solid possibility, one that we need to take very, very seriously. And the way that we're coming to that conclusion comes from three different scientific angles I like to call them the planetary context, the biological context, and the astronomical context. And I'll talk about each of those very briefly. The planetary context is kind of the most amazing one of all. I like to say that even aliens need a place to call home. If there are aliens, whether they're visiting us or somewhere else, they have to have come from somewhere. They didn't just magically appear in the universe. They must have had a home that's their home planet, their home world that they evolved on. So in order for the possibility of aliens to be taken seriously, there has to be other worlds out there on which those aliens could live. As of 1995, we had no evidence that showed conclusively that any other worlds existed outside of our own solar system. We had lots of good reason to think that they should. Our theory of how the solar system was born indicates that planets should be common around other stars, but we couldn't find any. Why? Because it was beyond our technology at the time. But starting in 1995, the technology began to catch up to that, and we started finding in that year the first clear detections of planets around other stars were made. Here we are 14 years later, and the number of known planets around other stars is now above 350 and growing rapidly. The Kepler mission that was launched in March found its first planet yesterday from data that's being analyzed over time, and if all goes well with that mission, it's going to find 1,000 of them over the next 4 years. And by doing the statistics of where we find them, where we have the technological ability to find them right now, we can make now a solid statistical scientific case that planets are common in the universe. We haven't yet found Earth-like planets, although Kepler probably should find some over the next 4 years. But everything that we know so far points in the direction of us being able to say scientifically today that homes for aliens are probably all over the place in the universe. The next question is that biological context. Just because you have a home doesn't mean anyone lives there. The biological context is what would make us think that having a home would tend to make it inhabited. And for that, we like to study life on Earth, and in particular, to learn about the possible origin of life on Earth. And I won't spend too much time with that. I'll come back to it a little bit more later. But basically, the bottom line is what we have learned is that in the history of Earth, life arose on this planet almost immediately, certainly geologically speaking, after it became possible for life to survive here, once the conditions became conducive to life. That right away tells us it probably wasn't that hard for life to get started, because if it was hard, it would have taken a lot longer. But we can also investigate it in the laboratory, and there's people studying the origin of life in the laboratory, trying to make artificial organisms and so on. And no one has so far created life in the laboratory. But we've created all the building blocks, all the parts. And based on what we now know, we can say with a fairly high degree of confidence that it doesn't seem like getting life is all that hard if you have the right conditions. So if you put that together with the first thing, that there's lots of worlds out there probably that would have the right conditions, and it's not that hard to get it if you have the right conditions, you put those things together and you say, hey, there's probably going to be life out there in other worlds. Can't say it for sure, but good reason to think that that's going to be the case once we have the ability to look for it. And the third thing, then, is the astronomical context. And that comes to the question of how many worlds, when I say a lot of them out there. And the numbers here are truly astonishing. For example, you've probably heard that we live in a galaxy called the Milky Way galaxy. Our sun is one star in the Milky Way galaxy. The Milky Way galaxy, we know how many stars it contains in a couple of different ways we can measure that. And we don't know exactly, but it's somewhere between 100 billion and 1 trillion stars in the Milky Way galaxy. Let's just be conservative, call it 100 billion. So 100 billion stars in our galaxy. What does that mean? It's very easy to say a number like 100 billion. Imagine that maybe tonight you're having trouble falling asleep after this exciting conference. You don't want to count sheep because that's too boring. So you decide to count stars. And you start. 1, 2, 3, 4. When will you get to 100 billion? It's a good question, right? It depends, of course, on how fast you count. Let's say we could count at 1 per second. Now, this is kind of fun. I like to do this with kids a lot, too. And kids always give me trouble about that one. 1 per second? I can count way faster than that. 1 2 3 4 5 10. Very good. But what about when you get to 82,395,465,732? How fast can you say that and remember what comes next? Counting to 100 billion at 1 per second would be quite a good rate. And if you could do it, it would take you 100 billion seconds, which, if you divide by 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 365 days in a year, you will find is a little over 3,000 years. Think about that. Just to count the stars in our galaxy, if you didn't ever take a break, didn't ever fall asleep, and didn't ever die, would take you more than 3,000 years. That's just to count them. If you want to spend time giving them names, seeing if they have planets around them, seeing if those planets have life on them, then it's going to take you a lot longer. That's incredible to think of the number of possible worlds that could be out there. And if I go back to what we were talking about a moment ago, based on the statistics we've seen before, it's quite reasonable to imagine that on average, there's an Earth-like planet in every one of those 100 billion systems. So 100 billion Earth-like planets out there is very reasonable. 3,000 years just to count them. And that's just our galaxy. There's 100 billion galaxies in the universe. So now you've got to do that exercise again, put it all together, and the best way I like to do that is to have my son, when he was about 1.5 on the beach here. You can imagine I had asked him to count the grains of sand in his shovel. You can see he got frustrated with the exercise. But had he succeeded, you know, you could easily count the grains of sand in a shovelful like that in a week or so if you were diligent. Right? Grains of sand are pretty teeny tiny. Do the rest of the beach. Do the rest of Oahu there, which is where we were at the time. Keep going. Count the grains of sand you can find on every beach on Earth. Add them all up. And what will you get? A lot of grains of sand. The amazing thing is, that number, if we do a little estimate of it, is about the same as the number of stars in the universe. The number of stars in the universe, the number of likely planets like Earth in the universe, is as many as the number of grains of sand on every beach on Earth put together. So if somebody says, I don't think there's any other life out there, it's possible. Scientifically, we haven't found it yet. But man, is it hard to believe. Right? That's where we share a common perspective. And science is moving in your direction, right? Because we're finding that these things are real possibilities. Now, that also allows us to say some things about what that life might be like, particularly if it happens to be coming here. And this is what I like to talk about from my perspective on UFOs, which is, what do I know about aliens who are visiting Earth? There's a couple things I can say about aliens who are visiting Earth, even though I'm not sure they are. But if they are, what can I say about them? I can say that they're really, really smart. And how do I know that? Because they had to come from a home in another solar system. And that means they came from really far away. How far away? Well, one of the things that I've spent a fair number of years working on in my career is building scale models of the solar system. If you get up to Boulder, those of you who are from around here, the first one I worked on is on the University of Colorado Boulder campus, out in front of the Fisk Planetarium. You'll find a pyramid with a sphere on it about this big, and that's the sun at 1/10 billionth of actual size. You might be thinking, on that scale, if that's the sun, how big is Earth in comparison? And the answer is, it's about the size of the ballpoint in your pen. The Earth is really teeny tiny compared to the sun. Where is it? On that scale, it's about 15 meters, 16.5 yards away, which, roughly to the back corner of the room here. So imagine I'm holding the sun right here, and you take a little ballpoint to represent Earth, and you put it way in the back corner, and imagine it making a circle once a year around that sun. That's what the orbit of Earth looks like in space. In between where that Earth is going around and the sun, all you have is two other smaller dots, Mercury and Venus. Further out, you've got the other planets, but none of them are very big. Jupiter's only the size of a marble. And they're all spread out. If you want to do the whole solar system, you got your 8 little dots of planets, if we don't count Pluto. You can count Pluto if you want. It's out there. And to show just those planets, you need to go about 1/3 of a mile to get to Pluto. We'll include it for now. And it's included in our models because we built them before 2006. And this one, by the way, on the screen is the one outside the National Air and Space Museum on the National Mall. So you can go there and see that one as well. And you can see the sun is that gold sphere where the kids are. on the 1 to 10 billion scale. The whole thing, if you show the orbits, would be spread out over 300 football fields to fit it all, and all you have is this one thing like this and all these teeny dots. It's pretty much all empty, which of course is why we call it space. But that's just our solar system. It's not where the aliens who are coming here have come from. They're coming from another star. So where is that? Well, before we go to them, let's go back to where we can go. We've sent spacecraft out to all these planets now. We even have one on the way to Pluto. It'll get there in 2015. It was launched in 2006, New Horizons. But on this scale, the farthest human beings have ever gone is the moon. Where's the moon? I've only been talking about the planets. Turns out if you put the Earth on my thumb, that little ball point, the moon is even tinier, and it would be right here. That is the distance on this scale from the Earth to the moon. On this scale, where the sun is, the full corner of the room away, this is the farthest human beings have ever traveled. Where's the next star? Turns out that on this scale, if we start with the one here in Washington, D.C., you start walking, like I said, you start in front of the Air and Space Museum, you'll get to Pluto in front of the Smithsonian Castle about 1/3 of a mile away. And if you keep walking outside of the D.C. metro area, cross a few state lines, a few more, and eventually, months later, if you walk diligently, reach San Francisco, you would on that scale finally have reached the next star. On this scale, where the sun is this big, the distance from the Earth to the moon is that far, the nearest star is across the United States, 2,500 miles away. What does that mean about aliens who are visiting us? It means that while this is the furthest we've ever gone, they're crossing the United States. Not only that, if they're coming here regularly, often, and so on, then it's kind of the equivalent of them being able to go back and forth to the United States as easily as I can move my finger in the palm of my hand. What does that mean? It could be that they're doing it. It just means, man, they're smart. Their technology is way beyond ours. What else can I say about the aliens? Well, I can actually go further, amazingly enough, than just that they're coming from really far away. I can say with reasonable scientific confidence that if they're visiting us, then technologically they are at least about 50,000 years ahead of us. Now, you may wonder, how can I say that? It turns out it's kind of simple math. There's a lot of guesswork involved, which is why there's about and hedge words like that. But let's go back to our 100 billion stars. So imagine there's 100 billion worlds out there that could be home to life. What if the chance of finding life on any of them is really, really tiny? What if it's as bad as your chance of winning the lottery? What if you can only, out of 1 million habitable worlds, only one of them is actually going to have any life on it? To me, that seems really unlikely. I think probably 999,999 of them are going to have life out of the million. But let's say it's only 1 in a million that has life and gets a civilization someday. What does that mean? If only 1 in a million of them gets life and a civilization, with 100 billion of them in the galaxy, that means there's 100,000 civilizations in our galaxy alone. That's incredible. However, there's no reason to think that they all got started at the same time. We would expect them to be distributed, rising up at random times in the history of the galaxy. And it's been possible for life, a civilization, to arise on other worlds, at least according to our current understanding, for at least the past 5 billion years. So if those 100,000 civilizations have been spread out over those 5 billion years, you divide and you get 50,000 years between them. And there you have the summary in case you want to see the numbers. So within the galaxy, just based on simple arguments, on average, you're going to get a civilization about every 50,000 years. That means if somebody's coming here, well, actually, it has an even more amazing implication, which I want to mention to you. It's a little bit sad. The sad part is we can scientifically say with very high confidence that we, today, are the dumbest civilization in the entire galaxy. because we just got here. And statistically, the next dumbest is 50,000 years ahead of us. And the next dumbest after that is 100,000 years ahead of us, and so on down the line to ones that are millions and billions of years ahead of us. So what does this all mean that I can say about aliens? It means that what I can say about aliens is that if they are visiting, then their technology should be something like what we will have if we continue to develop our technology for the next 50,000 years. And the only difficulty with that is I have no idea what that looks like. Nobody has really successfully succeeded in predicting what our technology is going to look like even 50 years out. The internet, maybe you can find a science fiction writer somewhere who imagines something sort of like it, but it came up pretty much as a surprise to everybody. We don't know what our technology is going to look like in 50 years, let alone 500, 5,000, or 50,000 years. Which brings me to a famous quote from Arthur C. Clarke: "Any sufficiently advanced technology is indistinguishable from magic." That means that, to me, I can say with confidence that if aliens really are visiting us, and again, I do believe that's a real possibility, but it means that as far as we're concerned, they can do magic. That allows us to say certain things about the plausibility of UFO reports. And I hope I won't offend anybody here. I want to distinguish between possibility and plausibility. Anything is possible. Plausible means that if we take what I've said so far, we'd have good reason to think it might be this way. So, for example, saying that sightings of spacecraft that move in amazing ways, that's very plausible. Because if they're that far advanced, they can do that. And so actually, personally, I have no difficulties with UFO sightings at all. In fact, that's what I would expect aliens who are visiting us to do. Why would we ever see them if they're magical? Well, there's still laws of physics. Maybe every once in a while they slip up a little bit, their cloaking device fails, whatever it is, and you catch a glimpse and they shoot off, right? UFO sightings are quite plausible. That doesn't mean I think they're real, but it does mean I think they could be real. Spacecraft that crash by accident and leave metal parts. It's possible, but it doesn't seem plausible to me. Because for one thing, think about our aircraft. How often do airplanes crash today? Not often. In 50,000 years, I think we'll be able to make planes pretty much crash-proof. So I think they can make their spacecraft pretty much crash-proof. And as far as materials, they're not using metal. I don't think we're going to be using metal in 50 years, let alone in 50,000. Metal instruments used as probes. Already, we're moving, I'd say in 50 years, we're going to have nanotechnology going through your veins to figure out what's inside of you. I don't think they need to stick big instruments into us. They could. It's possible that they do it for some reason, but it doesn't seem very plausible when you think about their level of technology. And my favorite one, and this is another true story, was I was starting to write about reverse engineering when Microsoft Word crashed on me. And I lost about 3 paragraphs and had to rewrite them. And I thought, you know what? They don't use Microsoft Windows to fly across the universe. So if we've been reverse engineering their stuff, we've been doing a really poor job of it. Let's go back to what we can now say, now that I've shown you where my perspective is and where I'm coming from. So in science, what we're going to try to do is understand what the possibility is that we can prove someday that life is out there, that civilizations are out there, or maybe even that they're visiting us. So we start by trying to understand life on Earth. I talked a little bit about that biological context before. I'm not going to spend much time on this. You can read lots more details in my book. But the really interesting thing is what we've learned in the last few decades is that life is not what we thought it was. A lot of you are of the same age range as I am, and you will remember that when we were in high school, they taught us that there was the plant kingdom and the animal kingdom. Turns out, if you look at that chart over on the far right, you can see the plant kingdom and the animal kingdom. They're 2 small branches of one of 3 large branches that make up what we call the tree of life today. Most life on Earth is not like us. It's not like any plant or animal. It's almost all microscopic, but it's not like us at all. We are not, it's really a great shift in human perspective. Just like the Copernican Revolution showed that our planet was not the center of the universe, in the last 4 or 5 decades, we've learned that we're not the center of Earth's biological universe, like we used to think. We thought we were the dominant things on Earth. We're not the dominant things. Get rid of us, most life on Earth doesn't even notice anything happened. Plants and animals will notice because we probably kill a bunch of them along the way. But most of the life on Earth, whether we're here or not, makes no difference. We can apply lessons that we've learned about life on Earth to finding life elsewhere. And again, one of the most astonishing lessons has been that not only is that life not like us, most of the life on Earth, it doesn't even like the same kinds of conditions that we like. For example, we like oxygen. Most life on Earth doesn't. We like nice, pleasant temperatures. There's lots of life on Earth that likes really hot temperatures that would kill us, or really cold temperatures where we can't survive. And what that means is actually really important for the search for extraterrestrial life. Because remember, before we were talking about finding Earth-like planets. You know what? It doesn't even have to be all that Earth-like. Because there's a lot of places where life could survive that are quite different from what we think of as Earth-like. And in fact, the only real requirement that we have found for life on Earth is liquid water. And there's some biological reasons that I won't go into now to think that liquid water, or at least some sort of liquid, is a requirement for life of any kind. But what that means is any place you got liquid water, or maybe some other liquid, you could, in principle, have life. And that means even in our own solar system, we have a number of possibilities. Mars, for example. There's no liquid water on the surface, but there is ice on the surface, and there's probably some liquid water underground, and there certainly was liquid water in the distant past. So Mars is a perfectly reasonable place to look for microscopic life. Europa, moon of Jupiter, that's a really interesting case. That's the second photograph there. That is a world that's completely covered in ice, water ice. The ice is probably about up to, maybe 20 miles deep, but under that, we're not totally sure because we can't see through it, but based on measurements that have been made by spacecraft, we're kind of at the 95% confidence level that under that thick layer of ice is an ocean, maybe 50 miles deep around the entire world. If we're correct about that, there's more ocean on Europa than on Earth. Which is quite amazing to think. What could be swimming in the ocean of Europa? Arthur C. Clarke wrote 2010 about that possibility. Titan and Enceladus, other possibilities that I won't talk too much about. Other than that, I want to show you this little sequence of pictures of Titan, because what you see there from left to right is Titan, viewed from an orbiting spacecraft, Cassini. And then the Huygens spacecraft was released from Cassini and sent parachuting down to Titan's surface, and you can see it on its way down, what it saw. And the picture on the right is the surface of Titan, seen from the Huygens spacecraft. The temperature is far too low for liquid water there, but it turns out it's about right for liquid methane. And we do now know that there are liquid methane and ethane lakes on Titan. So perhaps there's some weird form of life that can live in those lakes. But the amazing thing about it to me is Titan is 1 billion miles away. If you, take something and throw it at Titan to try to hit it, at that distance, it's the equivalent of taking your gun and firing at a dime 2,500 miles away from one end of the United States to the other. So we can take our rockets and do the equivalent of firing a gun 2,500 miles across the United States and hitting the dime. And not just hitting it, but landing softly on it. That's amazing. That right there gives me hope for the future of the human race. If we can do that, we ought to be able to do a lot of pretty great things. Unfortunately, we spend more of our time doing not so great things. But if we focused on doing the great things, we could do amazing things right now with the technology we have today. Imagine what the aliens could do with their technology 50,000 years beyond us. And I know that's one of the things that excites all of you, because if they're here, they've got some amazing knowledge to share with us. However, Within our solar system, other than maybe some big fish swimming in Europa, we're still looking at microscopic life. We've taken photographs of the whole solar system. There are no big things walking around anywhere. If we want to see big things, if we want someone we can talk to, we've got to look out to the other stars. And if they're coming here and we can prove it, that'll make our job real easy. But in the meantime, we can try to contact them or listen for them. And that's what the search for extraterrestrial intelligence is doing. And this next one is kind of thrown in from some of my scientific talks. It won't quite hit you guys the same way, but I think you'll appreciate it anyway. If we were all listening with our SETI telescopes, then we'd never hear anything. Somebody has to be talking too, right? So if we're hoping that they're broadcasting messages to us, we need to do our part and broadcast messages to them, right? It's only fair. Can't expect them to do all the work. So we've broadcast a few, and one famous message was broadcast in I believe it was 72 from the Arecibo radio telescope here. And so we broadcast this message out to the stars. This is the decoded message over on the right there. And we have not heard back, which is not too surprising because we actually broadcast the message at a globular cluster called M13, which is 21,000 light years away, which means it's going to take our message 21,000 years to get there, and if anyone does respond, 21,000 more years for their answer to get to us. So if we're going to hear back, we won't hear back for another 42,000 years. But that's okay. At least we've made a start at it. And if others are broadcasting, maybe we'll hear their signal. And one of the things that's kind of funny to me is sometimes I've had people say to me, maybe we shouldn't do that. It could be dangerous, right? What if they're mean aliens and they get our message and go, wow, that must be a nice planet. Let's go kill all them and take the planet over. And of course, the response to that is, it's too late. Why? Because our television signals have been going out into the universe since the 1930s and 40s. They're farther away than any other signals we're getting. If they have the technology to travel here, they have the technology to watch our television even from where they're at. And if you're worried about them getting mad at us and coming to kill us, I don't think it'll be because we send a 3-minute hello. It's more likely to be Gilligan's Island or whatever's reaching them right now. In any event, when you think about the level of technology that they must have, they might want to come here and study us, talk to us. There might be any number of reasons. We're interested in bacteria, right? They could be interested in us, even though we're the dumbest civilization in the galaxy. There's plenty of good reasons why they might come here. To take our stuff? Not really. I mean, if they can get here, they can make the stuff themselves a lot easier. And so, finally, what I like to focus on, since I don't believe we've shown that they're here already, why not? Where is everybody? This is a famous question in science, first asked in this particular form by Enrico Fermi, the famous physicist in about 1950, so it's sometimes called Fermis Paradox, which is why, if there's so many possible civilizations out there, why haven't we gotten proof that everyone agrees on yet? And scientifically, we can break down all the possible answers into 3 basic categories. The first category is that the reason we don't have any scientific proof that they're here might be because we are alone. Maybe they don't exist at all. That, scientifically, is possible. But in the same spirit as I was talking about some of the UFO things, it doesn't seem very plausible. Think about those grains of sand again. Very hard to imagine that this is the only place intelligent life ever happened. Possible? Yes. Likely? I would say no. But then where are they? Why aren't they coming here? Well, a second possibility is there have been lots and lots of civilizations. There are the 100,000 civilizations that have come up over the past 5 billion years in our galaxy. To me, that seems pretty likely. But maybe for some reason, they're not coming here and not communicating with us. But why not? Why wouldn't they be coming here? Why wouldn't they be trying to colonize the galaxy? Why wouldn't they be sending messages all over the place? Well, you can come up with any number of possible answers to that question. But the bottom line is, if you give us the chance, we're going to take it. That means unless everybody else is different from us, then they would take the chance too. And there's no reason to think we're different. If they're out there, we would expect that they grew up on a world like ours, they evolved under the same pressures as ours, and they have come to be much like we have. They ought to be like us, at least maybe not physiologically, maybe not 2 arms and legs and so on, but at least in terms of their motivations and so on. If they've built a civilization, it seems reasonable to imagine they would want to travel out to the stars. So if they don't, if none of those 100,000 civilizations have come our way in all those billions of years, the most likely answer is because they couldn't. Not because they didn't want to, but because they couldn't. Why couldn't they? This is the scary possibility, right? Because we all know too well today that the same technology that may allow us eventually to travel to the stars is the technology we are currently using more often to kill each other or damage our planet. Maybe, in fact, we know for a fact we can say, based on the technology, that it is inevitable that once you get the technology to build a civilization, communicate, travel out into space, you also have the technology to destroy yourself. Maybe that's what happens. Maybe every single one of them has destroyed themselves. I like to show this graph. Well, I don't like to show it. I don't have a choice. Carbon dioxide concentration in Earth's atmosphere over the last 400,000 years. What you can say from a graph like this, you don't need to talk anything else about global warming, evidence for global warming, anything else. All you need to do is look at this graph and you can say, gosh, things are different today. They are. Does that mean it's going to be a catastrophe for us? Not necessarily. But we have lots of solid scientific evidence to say it's not going to be good for us. Maybe this is how they wipe themselves out. Maybe they do it with nuclear war. Maybe they release some disease. But possibility number 2 here is they all destroy themselves. So possibility number 1 is they're not out there. But that doesn't seem very plausible. Possibility number 2 is they all destroy themselves. That, in some ways, seems all too possible. But we hope it's wrong. Because if they've all destroyed themselves, we're probably not going to make it either. So we hope that that's not the right answer. That there is a way to get past this bottleneck of history where you have that technology to destroy yourselves as well as to move on. Hopefully there's a way to get past the destroy yourselves part. But what does that leave? If we say number 1 doesn't seem very likely and number 2 we're rooting against, it leaves only one possibility left, which is that there is already a galactic civilization out there that somebody built tens of thousands, hundreds of thousands, millions or billions of years ago. They are out there all around us. And this is where I think the science and the UFOs come together the most. Because even though we've started from very different perspectives and we're studying in different ways, I come to the conclusion that if you ask me to place a bet, my bet is there's a galactic civilization out there that's way more advanced than we are. And the only place we disagree is on whether we already have proof that they're here. But the possibility is incredible because it means, if I'm right, or if you're right, either way, because we're talking about the same thing, it means that someday, if we don't destroy ourselves, we will meet them. And in the unlikely event that they're not already out there, that we're the first, which is still possible if it doesn't seem likely to me, then we'll be the ones who start it. In other words, it brings us to why I subtitle my book, The Astonishing Implications for Our Future. In all of human history, there have been generation upon generation of people, but we are the ones who live at the turning point of history. In the next couple of generations, we will decide whether we use our technology to wipe ourselves out and destroy our civilization and go back thousands or millions of years, or whether we use it to chart a path that will take our descendants to the stars. And so whether or not there really is intelligent life out there. Whether or not you believe it's already here, there is one important question that we have not, as a civilization, yet answered, that we need to answer. And that is there actually intelligent life on this planet? And that is where I will stop. I do have time to take questions. I think we've got about 15 minutes or so for questions. But before I do, there are my two websites. I have beyondufos.com is only devoted to the Beyond UFOs book that I've been talking about. JeffreyBennett.com is where you can see all my other books, including my children's books. And I do have a few copies of all of these here that after we're done here, I'll go over to the vendor area. I have a little table set up, and you can come over if you want to get autographed books and so on. I'd be happy to do that for you. Thank you. Yes, so I guess you're coming up to use the mic if you have questions.
Paul Hicks, MUFON, Iowa. What is your opinion of the Betty Hill star map?
I have to honestly say I don't actually know much about it at all. One of the things that I think surprises people in an audience like this is that I haven't spent time looking at UFO stuff, because you might think I would, given that there is a lot of stuff that people have seen and so on. But, I think everybody has to choose where they're going to put their time and effort in their career. I actually don't do scientific research anymore. I did for my PhD. Now I write for the public and for college students about science. So I rely on other people to provide me the scientific information. I study it and I learn it. And so it's just an area where, with what I've done, I haven't had the time to spend on that.
Dan Yatlin, Dallas, Texas, MUFON. What would it take scientifically to convince you that UFOs are real?
That's a very, very good question. I have a... if you take it from another perspective, I'm rather agnostic about everything, including my religion and so on. I think, well, what would it take for God to convince me he's real? And I think, I once had a dream where God came to me and allowed me to watch the creation of the universe. And I think, God, that ought to have convinced me. But I think it was just a dream. So it's going to take a lot. I don't know exactly, but it's going to take something that I can go study, that anyone in principle, and that's where science is. It has to be something that anyone can in principle go and check for themselves. Einstein's theory of relativity is accepted not because Einstein was smart, but because anyone can use that theory to make a prediction and test that prediction. Now, true, you'd have to go spend a few years studying it in order to do that. But anybody can do it, and lots of people every year decide to do that and go to grad school and do those things. So it takes something along those lines for me.
Doctor, thank you for a great presentation. Leonard Mandel from Goodyear, Arizona. I was going to ask the same two questions that they asked, but let me add. On the Betty and Barney Hill incident, the folklore is the Greys, or whatever they are, came from Zeta Reticuli, which is 13 light years away. 39. Okay, assuming that's the folklore, would you comment on the probabilities that a civilization 39 light years away could get to the planet Earth? What would it take?
Well,
assuming that's a hypothetical.
It takes that enormous technology that we were thinking about. But here is one place, and I was actually reading some articles that people were writing about with this conference coming up, and I saw some of my scientific colleagues saying that they thought it was implausible for somebody to be traveling that far. On that point, I disagree. I think if you give us 50,000 more years to keep developing our technology, we're going to be getting there. Now, there is relativity, which says you can't go faster than the speed of light. On the other hand, general relativity seems to allow for wormholes and warp drives and stuff. Maybe. We don't know if that's really possible or not. If it is, we'll figure it out someday. But even if it's not, even if you can't go faster than the speed of light, then 39 light years would take you 39 years, at least. If you're going 1/10 the speed of light, which seems quite reasonable, it would take you 390 years, which sounds like a really long time. But what if our medicine improves and we live 100,000 years? 390 years might seem like a trip to the corner drugstore.
Thank you.
Okay? So I think there's any number of ways that someone could, in principle, be getting here if they've survived. So the idea of travel among the stars doesn't bother me in one bit. The parts of those stories that often do give me trouble is the types of things that are then reported, like the metal instruments and so on. I think they'd be using something a little bit more sophisticated. But, they could be coming.
Hi, Tom Bowden, Oregon MUFON. I am actually going to make a couple of statements and like to hear your response. First of all, I really think it behooves you to find at least one good book on UFOs, and I'm sure you can ask many people here and get some recommendations. One reason I say that is because, you have done this, Seth Shostak has done this. When you start talking about UFOs, you immediately jump to extraterrestrial spacecraft. That's not the right way to think about UFOs. You had a UFO sighting, and you understand that you cannot assume that it's an extraterrestrial spacecraft. What we're saying is that some UFOs appear to be intelligently controlled craft. They behave like intelligently controlled craft. Whether that means they come from another planet, we don't know that. Just like you're saying, we don't know. We can't prove it. But the problem is we cannot get funding to carry out the studies needed to find out whether it's true or not. And why is that?
I understand that argument, and I've seen it. And, it's true. The funding isn't there for that. The question is, why not? I mean, if somebody came up with evidence that did convince us all, the question before, you'd get the Nobel Prize. And then the funding would be there for all kinds of stuff after that. And if you look at the history of science, you will find that almost every major thing that we're studying today didn't get the funding originally. Nobody was funding global warming research 20 years ago. It wasn't until the people who were working on it came up with evidence that was so strong that said, boy, we really need to be studying this, that the funding started to come. So I think, I personally don't believe it's any kind of conspiracy. I think it's that you've got to present people with something that's strong enough for them to want to start spending billions and billions of dollars on it. And I know a lot of you believe that it is already strong enough, and I can't really comment on that. That might be just an area where we agree to disagree. But I think if that case does look strong enough to lots of people, you'll get the funding then.
Hi, Richard Gottlieb from Phoenix. Could you say something about convergent evolution and the probability that UFO occupants could be bipedal, have binocular vision, etc.?
Yeah, I think the idea of convergent evolution is that there are going to be certain things that evolution is drawn to no matter how it's going about that. So, for example, the eye appears to have evolved independently in many different lines of species on Earth and evolved quite similarly, even though it went along different paths, you get the same end result. I think that I would be surprised if you didn't find animal forms on other planets that looked a lot like animal forms here. And the real question is, are we too limited in our imagination of what's possible, or have we found it? For example, there's 30-something different phyla, different body types among animal species on Earth. Are there more than 30 that are possible? Now, if you ask biologists to think of another one that doesn't exist, that would be possible, it's real hard for them to think of anything, because these 30 plus seem to cover the whole range. But that might mean we're just too limited in our imagination. But I think that ultimately, if aliens are traveling towards, I do think convergent evolution is going to give you something where you're going to get intelligence. I think there's a drive towards intelligence. I think there's going to be a drive towards having limbs that allow you to move things around and build things. Whether it's 2 of them, some other number, hard to say. But that would be my guess.
I'm Gail Barton. I live in this general region. I've been in MUFON for a bit. I've been collecting material on UFOs and other anomalous phenomena since about 1969. And I have noticed this Fermi Paradox being brought up a lot. And it has always struck me that another explanation for where are they is they're all over the damn place, but nobody wants to look at them. Would you comment?
Thank you. I can't comment generally. I can comment for myself. I want to look at them. I want to find them. Seth Shostak is dying to find them with his SETI efforts. And in fact, pretty much everybody I know in science really, really wants to find them. So I think we do.
Here's what should be a pretty simple technical question, I think, but we were just told recently that getting Zeta Reticuli will take 39 light years, 39 years, and if we go at 99.99% of the speed of light, it would only take 6 months. The question is, how much fuel do we have to take along, presuming it's nuclear by that time? 6 months worth or 39 years worth?
So what you're asking about is the relativistic thing. So it's 39 years from our perspective, or someone on Zeta Reticuli's perspective, from the time they leave till the time they get here. But it's 6 months from the perspective of the person in the spacecraft. But what you need to do, the fuel part is getting to that speed. And what you can show, for example, the reason it takes a big rocket, like the space shuttle, to get into orbit, isn't because we need a lot of energy to get up there. It actually, if you could just use an electric cable, like if we had an elevator, in my book, Max Goes to Jupiter, I talk about the space elevator, an old Arthur C. Clarke idea, going from Earth to orbit. The amount of electricity it would take to get up there is about $3 worth. Why do we need a giant rocket? Because you need that little bit of electricity to get you up there, but you need to generate it on board. That just made it higher. You made your rocket heavier, which means you need a little extra to make up for that weight. And you keep going, and you ends up, you need this gigantic rocket to get off the ground. With chemical rockets, you can't get much faster than we're going now. With nuclear rockets, you could get to maybe 1 or a couple % of the speed of light. In order to get to a high percentage of the speed of light, you're going to need, even like matter, antimatter, probably can only get you to about half the speed of light. You probably have to be collecting the fuel as you go and have systems. There are people who've imagined ways that we could do it, but it's a tremendous technological challenge, but not impossible.
The question, though, is not, the numbers may be a little bit,
well,
you say impossible. The question is,
you need 6 months worth of meals.
See, it is 6 months, not 30.
It's not the 39 years.
Okay.
You need 6 months worth of meals. But if we go there, you need a year's worth of meals, 6 months for each direction. But when you get home, 78 years will have gone by. So your friends will all be 78 years older than when you left.
Hello. Breakthroughs in technology needn't be a function of the budget. They can be a function of researchers thinking outside of the box. For instance, Einstein, his breakthroughs were not based on money, but were based on thinking in ways that no one has thought of before.
That's right.
And you said you and your colleagues and other researchers and scientists would love to find evidence of a galactic civilization. Well, which of you are going to make the breakthrough, and how are you going to do it?
Very good question. I think that, for example, Seth would say he's going to do it with SETI. He's going to get that contact with his radio telescopes and so on. So there's a number of different ways of going about it. Interestingly enough, SETI is completely privately funded. And that's another important point to keep in mind. This idea of government funding and stuff for things has only been true since the 1940s. Before that, almost all scientific research was privately funded. If you go back to before the 1900s, astronomers were almost always rich because they paid and built their own telescopes and they could afford to spend the time. You didn't find average people becoming astronomers because they couldn't afford to do it. Nobody was paying them to do it. So, yeah, there's lots of ways of getting across. And in the future, I think, there's always going to be funding avenues besides just what the government agencies are doing. So, but people who don't have independent wealth do have to have a job. So they need somebody to pay them in order to do whatever they're going to do.
Yeah, Ed Burke, Virginia MUFON, and this ties into SETI. You just mentioned that this advanced civilization, the closest one to us, is going to be at least 50,000 years advanced. Now, a civilization that's 50,000 years ahead of us, are they going to use primitive electromagnetic communications in the way we do it, too, because they might decide to do it spread spectrum so you'd never detect it. So do you really think SETI is going to work?
That's a very good question. I actually have talked a lot about this with Seth. He's a lot more hopeful about that than I am for that exact reason. But there's a couple things to keep in mind. First is that the galaxy is 100,000 light years in diameter. So even if they're 50,000 years ahead of us, if they're 50,000 light years away, right now we're getting the signal from when they were at our level. So there's that possibility. There's also, and my favorite movie on this and book on this is Carl Sagan's Contact. If they want, it could be that they have a reason for sending out those signals and wanting to know when does someone get smart enough to pick them up. I think it goes back to one of the famous quotes from Phil Morrison about the whole SETI program. He said, probability of success, I don't know. The probability of success if we don't try, 0.
That's true.
So thank you, Dr. Bennett. I know that there were some more questions. We unfortunately did have to stop. We're going to take a 10 to 12-minute break. Please be back here in about 10 minutes. But before you go, there's a very important announcement for one person in this room. For those who attended the luncheon, somebody may be missing a camera. And if you are, go ahead and either let me know or go to... Did I lose myself? Just go ahead and go to the front desk. So if you're losing the camera, if you lost the camera, go to the front desk or talk to me, and we'll get it back to you. Other than that, take about a 10-minute break, come on back in, and we'll be in. And if anybody does have any more questions for Dr. Bennett, he will be going to